So we're going to be taking a look at complex fractions today and how to simplify them. So what a complex fraction is something that can look like this. So we have a rational expression. That means we have a fraction. And if the numerator, the denominator, or even both have a rational expression in them, so if in a fraction, the numerator or the denominator or both are fractions, then what we call this is a complex fraction. So basically, it's just a fraction within a bigger fraction. And sometimes you'll see that only in the numerator, sometimes only in the denominator, and sometimes in both, like in this example. So I'm going to show you how to simplify that. So what I'm going to do is I'm going to rewrite this using the actual division symbol instead of the division line. So this is really the same as 5x over x plus 2 divided by, right, because that's what the division line means, 10 over x minus 2. And when we place it like that, it almost becomes a little bit more doable. It doesn't seem as overwhelming to look at. So we know that when we're dividing fractions, we can keep the first fraction the same, we can change division to multiplication, and we can flip or reciprocate the second fraction. So that's what we're going to do. So I'm going to rewrite this problem, but in multiplication. 5x over x plus 2. So the first fraction always must stay the same. And then we change to multiplication. And when we change to multiplication, we have to reciprocate the second fraction. So basically, we flip it. So this denominator becomes the numerator, and the numerator becomes the denominator. All right, and if you can simplify anywhere, you can. So just be careful because you have to remember that these are binomials that cannot be separated. So these x's could not cancel, and this -2 and +2 would not become +1. So be careful with that. But we can simplify the 5 and the 10. Remember that this is technically 5 times x. So this can be separated. We can divide 5 by 5 and we get 1. We can divide 10 by 5 and we get 2. So now we're ready to actually multiply like the fraction is asking us to do. So I'm going to do 1x, so just x, times x minus 2 in the numerator. And in the denominator, I'm going to have x plus 2 times 2. So I'm going to write it like this so that we can distribute. So let's go ahead and distribute this. We end up with x squared minus 2x all over 2x plus 4. And because we can see that in factored form, nothing cancels, this is our final answer. This is the simplified form of this original complex fraction. These actually have the same value. So for example, if you chose to give x a value of, let's say, 3, if you plugged in x equals 3, every single place you see an x, the answer that you would get here is the same as if you plugged in x equals 3 in all of these places as well. But this looks much better than what this does. Here we have 3 fractions, technically, 1, 2, and 3. And here we only have 1. So that is our simplified form.